Hey everybody, it's the start of a new semester, start of learning something new. This semester we're going to start off by learning about factoring. We're going to be factoring polynomials so that we can solve them. But before we start factoring big polynomials, we're going to be just looking at how do we factor numbers? What does it mean to factor something? So we're going to start off by looking at two things. Prime factorization and then finding the greatest common factor of several terms. So just as a refresher, a factor is a number that multiplies to make another number. Or you could say it divides a number. It's basically like a component of a number. Easy example would be something like 12 is a factor of 24 because 24 or 12 times 2 is 24. Of course, 24 has a bunch of other factors like 3, 4, 8, 6, but this is just one factor pair. Factors will normally come in pairs because when you get one factor, something that divides 24, well, something has to multiply that number to make it equal 24. So we would call 12 and 2 a factor pair for 24. Another way we could look at factoring numbers is by just finding every single number that it could possibly be by boiling it down into its prime factorization. So this would be like splitting an atom. We're basically breaking, like in this example, water into H and O. So H2O, or sugar H6C6H12O6, or whatever. So prime factorization, we're just going to find the core of that number. So let's just start it off. We're going to try to break it down piece by piece until it can't be broken down anymore. We'll look at 140. You can usually start out a bunch of different ways. I'm going to break this down first by doing 14 and 10, just because that seems pretty simple to me right off the bat. 14 can be broken down further because it's 7 times 2. See here, 7 is a prime number, so we stop there. So we're going to stop there. 2 is also a prime number. We're done there. 10 can be broken down into 5 and 2. And those are both prime numbers. We're going to stop there. So if we were to write out the prime factorization of 140, we would write 7 times 2 times 5 times 2. Or 2 times 2 is just 2 squared. So we could write 2 squared times 5 times 7. It's probably the best way to write it right here. So that is the prime factorization of 140, kind of like the formula for how you get 140. So something that we also want to get familiar with is listing all the factors of a number. It's not something that we need to do all the time, but it's something that we need to be ready to do, because if you're looking for a common factor between two numbers, sometimes the only way to do it is just think about what are all the factors of each. So let's go ahead and write those out. One way we can do it is by looking at factor pairs. So I'm just going to write something that I know every number is divisible by, 1. And what's the other part that goes with 1? Well, 1 times 36 is 36. What else is 36 divisible by? It's divisible by 2. Well, 2 times what is 36? 18. So 2 times 18 is 36. Let's look for another one. 3 divides 36. 3 times 12 is 36. There's another factor pair. 36 is also divisible by 4. 4 times 9 is 36. And 5, no. 6, yes. And 6 is kind of a pair because 6 and 6 make 36. So we can kind of stop there because 7 doesn't divide 36 and neither does 8. So let's try this for 48 and see if we get any common factors. Obviously 1 is a common factor. So what goes with 1? Well, 48, 2, and 24. let's see here, 3. Whoops, 3 and 16. Had to think about that for a second. 4 and 12. Any more? 5, 6. 6 definitely divides it. 6 and 8. 7, 9. I think that's all we got. Yeah. So now we can just circle all the common factors. So 1's a common factor, 2's a common factor, 3's a common factor, 4's a common factor between these two numbers. 6 is a common factor, 8 and 9 are not, 12's a common factor, and that's it. And then something that we're almost always interested in is what is the greatest common factor of these two numbers or these two terms? And in this case, it's 12. 12 is the greatest common factor of these two numbers. Show you guys another way to find the GCF. So listing out all of the factors, as you saw, could be kind of a pain. And sometimes it's hard to think about what they all are. But let's try another way. We can kind of do something similar to division. We'll use sort of an algorithm. So I'm just going to draw sort of a box around this. And we're going to see, you can kind of think about this as pulling out factors. And we're going to pull them out a little bit at a time. So 36 and 48, what are they both divisible by? Well, they're both divisible by 2. And when you divide them by 2, let's see what we get. Well, 48 divided by 2 is 24. 36 divided by 2 is 18. Now we're going to see if we can pull out anything again. Well, we can pull out 2 again. You might be able to find a bigger number right off the bat, and if you can, that's great. But if you can't, just start with small numbers like 2. So if we pull out another 2 out of each of these, we would get 9 and we would get 12. Now we'll try to see if we can pull anything else out. We can't pull 2 out because 9 isn't divisible by 2. 12 is, but we need something that divides both. 3 divides both of these. If we divide 9 by 3, we'd get 3. If we divide 12 by 3, we get 4. And at this point, there's nothing that divides both 3 and 4. The factors of 3 are only 1 and 3, and 3 doesn't divide 4. So these numbers are called relatively prime. So the greatest common factor now, using this algorithm, can be found out over here. The greatest common factor of 36 and 28, or 48, is 2 times 3, 2 times 2 times 3, which is 12, which is just what we got before, but it was kind of more of a pain. What I'd like for you guys to do is just try this again using that algorithm with these two numbers here, 32 and 24. Make sure you practice that by yourself. All right, next we're going to look at finding the GCF of terms including variables. So this looks trickier than it is, but we're actually going to use the same type of strategy. We're going to kind of go back to the listing strategy though. So we're going to break each of these down. We're going to kind of write the prime factorization of each of these terms. It's not that bad, and in pretty much everything we do in actual class, it's not going to be that bad. So I'm going to write out this term. Remember, this is one term. Since it's all just multiplication here, we treat that as one term. So I'm going to write this out as 2 times 2 times x times x times x times y times y times y times y. Whew. Maybe I should have started this a little farther over here. There we go. And then this guy, prime factorization of 6 is 2 times 3, and then x squared is x times x, and then y to the 5th means y times y times y times y times y. And then we're just going to see what factors these both have in common. Well, let's take a look here. We've got a 2 over here to match up with a 2 over there. We've got a 2, but no 2 over here. We've got a 3, no 3 over there. We've got an x and an x. We've got an x and an x. We've got an x here, but no x there, so I'm not going to circle anything. We've got a y and a y and a y and a y and a y. 2 more y's here. And so 2 more y's there. And so what we can factor out of this is, let's see, we've got a pair of 2, so we got 2. We got x, we got 2 x's here. X, x, y, 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 y. Let's write that a little better. 2x squared y to the 4th. You'll notice that what you get here is a factor of both of these terms. That's kind of what we did on purpose. It's a factor of both of those terms. Not only is it a factor, it's the greatest common factor for both of those terms. So we can use that to factor larger things. What I like for you guys to try is to try to find the GCF of all 3 of these terms. And what you want to do is you want to do that by writing out the prime factorization of each term, and then finding what they all have in common. Remember, they have to all have them in common. If 2 of them have it in common, not good enough. And we'll do more practice with this in class, and we'll start to see how it's going to be useful for solving something called quadratic equations.